Hello all, welcome back to my channel. So in this video we will see how to derive a Darcy Weisbach equation. Darcy Weisbach equation is one important equation which is used to determine the major head losses in pipes. So major head losses mainly occur due to the frictional losses that happen. Okay, and to determine this frictional losses we have two equations. One is Darcy equation and the next one is Chezy's formula. So in our today's video we will see how to derive Darcy Weisbach equation. So for this please observe the figure. So let's say that there is a pipe in which water or any fluid is moving. This pipe is horizontal and it is having, let's assume it is having steady flow. So you can see here we have considered two sections 1-1 and 2-2. Section 1-1 is at the inlet and section 2-2 is at just before the outlet. So we can observe some terms here. So P1 is the pressure intensity at section 1-1 and P2 is the pressure intensity at section 2-2. Similarly, V1 will be the velocity at section 1-1 and V2 will be the velocity at section 2-2. And let's say L is the length of the pipe, this complete pipe, and especially in between the sections, and let small d is the diameter of the pipe. You can also see here F1 written. F1 is the total frictional force acting by the surface, by the walls of the pipe on the fluid. Okay, so basically we derive the Darcy equation by considering first Bernoulli's equation, then afterwards we also consider the equilibrium of forces. So these two concepts we generally apply to derive for Darcy equation. So quickly let's move on. So first let me apply Bernoulli's equation in between the two sections 1-1 and 2-2. So when we apply Bernoulli's equation we write P1 by rho g plus V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2. This is for ideal fluid, but this is a real fluid and also there is head loss taking place, HF. So like this we write the Bernoulli's equation at the two sections, but initially I told this is a horizontal pipe, so we can say that Z1 is equal to Z2. So now our equation will turn out to P1 by rho g plus V1 square by 2g should be equal to P2 by rho g plus V2 square by 2g plus HF, because Z1 and Z2 are same, they get cancelled out. But I also told that D is the diameter of the pipe, which is not changing between the complete sections and after the sections, means the entire pipe is having same dia. So when there is same dia, the velocities also will be same, which is V1 equal to V2. So finally your V1 square by 2g, V2 square by 2g also will get cancelled. So therefore we are left with P1 by rho g should be equal to P2 by rho g plus HF. So from here we can write HF as P1 minus P2 by rho g. Okay, let's take it as equation number 1. So this equation 1 came just by applying Bernoulli's equation at the two sections. I also told that after applying the Bernoulli's equation we use another concept called resolution of forces. So for this what shall we do is that, so you can see in the equation number 1 HF is your head loss due to friction, and basically intensity of the pressure will be reduced along the direction of the flow because of the frictional resistance. So when the fluid is moving from left to right, obviously the friction will act from right to left. That's why it is trying to oppose, friction basically tries to oppose the flow. So that's why you see P1 is in this direction, but whereas F1 is in this direction. So let's write for F1 first. So F1 is what? F1 is the total frictional resistance offered by the complete walls of the pipe or the complete surface of the pipe on the fluid. So this basically this frictional resistance will be equal to product of frictional resistance per unit area, per unit wetted area per unit velocity, what we denote by the symbol of small f dash. The small f dash is called as frictional resistance per unit wetted area per unit velocity, because this complete pipe is a collaboration, or the complete pipe is a summation of all small units. So that frictional resistance offered by one single unit is F dash into the total wetted area, the total part of the pipe which got wetted, which is pi dl. You can see the surface of the pipe got wetted. Surface of a pipe looks like a cylinder, so surface area formula is pi dl into total velocity. Actually here we have to put only velocity, but now we are writing velocity square, because even though we assume the flow to be steady, but in practical we do not expect a steady flow. So when there is friction, we expect a turbulent flow, and according to Reynolds experiment, the friction is directly proportional to v square. That's what we are writing here. So finally I write this equation as F dash into P into L into v square. So I wrote pi d as P in P, because we know that perimeter is pi into d formula. Okay, so let this be our equation number 2. Now if we observe the figure, we have three parameters here, P1, F1 and P2. So we will have one force because of this pressure. We already have frictional resistance. We will have another force due to P2. So let's write the three forces due to P1 and P2, and also the frictional resistance, and then let's apply the equilibrium concept. Okay, so basically what are the forces acting? I told forces acting are one force due to P1. So due to P1 means the force formula will be P1 into A, because pressure is force by area. From here I am asking force, so force will be P1 into A. Similarly, the force due to pressure P2 will be P2 into A, and what was the third one? The frictional resistance F1, what we have written. Now we will apply equilibrium concept for these three. So you can see here in the figure, P1 is moving towards the right, F1 is moving towards the left, P2 is also moving towards the left. So when we apply equilibrium in summation of all forces equal to 0, we take right side forces to be positive and left side forces to be negative. So finally what does our equation turn out to be now? It will be P1 into A, because P1 is moving in the right hand direction, minus P2 into A minus F1 is equal to 0. So from here I can take out P1 and P2 common, into A minus F1 is equals to 0. Okay, so but already we know, okay, before that we will write P1 minus P2 into A is equal to F1, which implies P1 minus P2 into A equal to, from equation 2, what is F1 equal to? F dash into P into L into V square. Okay, but so from here what we can write? P1 minus P2 as F dash PLV square by P1 minus P2. Okay, but if you people observe equation number 1, what is HF equal to? P1 minus P2 by rho g. So from here what can I write? P1 minus P2 as HF into rho g. So I will write here. So HF into rho g is equal to what now? Sorry, this is A, no? So just a second, I'll make the correction. So this is A. So finally HF rho g will be equal to F dash P L V square by A. Okay, and so what is my concept about calculating HF, right? So from here what can I write HF as? Just keep HF this side and send rho into G that side. So it becomes HF is equal to F dash PLV square by A into rho G. Okay, so from here we will just try to rearrange the terms. So I will write this as F dash by rho G into P by A into LV square. So this is your equation 3, which is your basic virgin raw equation for your Darcy Weisbach equation. We will further simplify this as P by A equal to, what is P? Wetted perimeter by what is A? Wetted area, or area of cross section, which is equal to pi d by pi by 4 d square, because it is a circle. So from here P by A becomes 4 by d. Let's substitute this P by A in HF. So finally what is HF equal to? F dash by rho g. In the place of P by A, what we have to put? 4 by D into LV square. So this is also one important equation for Darcy, and later we can convert this F dash as just by putting F dash by rho is equal to F by 2, where F is called as your friction factor. We finally get HF is equal to how much? F by 2G into 4 by D into LV square, and finally HF turns out to be 4FLV square by 2GD. This is called our Darcy Weisbach equation, which is very important. Okay, and this equation is used for what? For calculating friction in pipes, loss of head due to friction in pipes. Okay, and let's solve some numerical problems related to Darcy equation now. So let's see the first question on Darcy Weisbach equation. So read the question. Find the head loss due to friction in a pipe of diameter 300 mm and length 50 meters through which water is flowing at a velocity of 3 meter per second using Darcy equation. Take kinematic viscosity of water as 0.01 stoke. So for us, the data given is, always remember whatever might be the problem, first we need to write the given data so that we'll have a clarity of what is given and what should we calculate. So D is given as, for us, 300 mm. So this is equal to 0.3 meters. Next, length of the pipe is given to us 50 meters. Next, velocity of flow is given to us as 3 meter per second. Kinematic viscosity of water is given to us, which is 0.01 stoke, but stoke is a CGS unit of kinematic viscosity, which we need to convert into SI system. So multiply with 10 power minus 4 into 10 power minus 4 meters square per second. So what he is asking us to calculate? He is asking us to calculate the head loss. So basically what was the head loss equation? 4FLV square by 2GD. So we want HF. So to calculate HF, we have L value ready with us, V value ready, D is ready, F is missing. What is F? I told you, friction factor. So to calculate friction factor, first I'll tell you two important formulae for friction factor based on Reynolds number concept. First let's calculate Reynolds number. Reynolds number is given by the formula Vd by nu. If you have mu, dynamic viscosity, then it is rho Vd by mu. Okay. So here it is kinematic viscosity. So 3 into what is the dia? 0.3 by 0.01 into 10 power minus 4. So the Reynolds number came out to be 9 into 10 power 5. So if Reynolds number is greater than 4000, we call it a turbulent flow. At that time we have to take F value as 0.079 by Re power 1 by 4. Similarly, if our Reynolds number value is less than 2000, which is a turbulent flow, then we write friction factor as by the formula 16 by Re. So when your F is not directly given to you, people remember, calculate first Reynolds number. So now if you see in our problem, it is 9 into 10 power 5, which is greater than 4000. So let's take up the formula for friction factor as 0.079 by Re power 1 by 4, which is equal to 0.079 by 9 into 10 power 5 to the power of 1 by 4, which, let's see how much it comes out to be. So this came out to be 0.00256. This is F value. Now let's calculate HF, which is given by the formula 4FLV square by 2GD, which is equal to 4 into 0.00256 into L is how much? 50 into V square is 3 square by 2 into 9.81 into 0.3. So finally our HF came out to be 0.7828 meters. So this is one basic model of problems we can solve by applying Darcy equation. Just by first calculating F value. Once you know F, you can apply HF. Let's see next problem. Calculate the discharge through a pipe of diameter 200 mm when the difference of pressure head between the two ends of the pipe is 500 meters of the pipe 500 meters apart is 4 meters of water. Take F as 0.009. So people, if you observe this problem here, they are asking us discharge, which is Q value, and they are giving us the dia of the pipe, and also they are giving us the difference of pressure head. So difference of pressure head value is given to us. Next, length of the pipe is given. 500 meters apart means it is length of the pipe, and F is given. So first again let's go back to our given data. So please watch carefully when we are doing for given data. So first, what is given to us? D, which is 200 mm, which is again 200 by 1000, 0.2 meters. Similarly, length of the pipe is given to as 500 meters. They told 500 meters apart means it is length. Difference of pressure head is given. So you might think, what is this difference of pressure head? Suddenly it is nothing but our HF. How? So if you see here in our equation number 1, we wrote HF is equal to P1 minus P2 by rho g. P1 minus P2 by rho g is what? Difference of pressure head only. So directly HF is given to us. So see, instead of giving HF, he wrote difference of pressure head. So people will get confused here. So it is HF. F is given to us 0.09. So finally, let's apply the formula of 4FLV square by 2GD. So from here, HF is 4 into what is friction factor 0.009 into what is L 500, we don't know velocity, let it be like that, by 2 into 9.81 into what is your D, diameter is 0.2. So from here let's try to get out for V square. So V square will be equal to what? Send all the terms on the other hand side. So it will be 4 into 2 into 9.81 into 0.2 by 4 into 0.009 into 500, and V will be under root of this complete answer. So finally our V comes out to be 0.934 meter per second. Once you know velocity, what you have to do? You have to calculate the discharge. So discharge Q is equal to, what is the formula for discharge? Area into velocity. So Q equal to, area formula is pi by 4 d square into velocity is 0.934. So Q is equal to pi by 4 of 0.2 square into 0.934. So this value will come around 0.0293 meter cube per second. If you want to write this in liters, multiply by 1000, it is 29.3 liters per second. So like this we have to calculate discharge. Okay, let's solve the another model of problem, last model. An oil of specific gravity 0.7 is flowing through a pipe of diameter 300 mm at the rate of 500 liter per second. Here discharge is itself given to us directly. He is telling it is an oil whose specific gravity is 0.7. It is flowing through a pipe whose dia is 300 mm. So first let's write the given data till here. So given data is what? D is equals to 300 mm, which is equal to 0.3 meters. Specific gravity of oil is 0.7. So density will be equal to S into 1000, basic formula. So 0.7 into 1000. So density of oil will be equal to 700 kg per meter cube. Next, discharge is given to us as 500 liter per second, which is equal to 500 into 10 power minus 3 meter cube per second, because 1 meter cube is 1000 liters. Next, find the head loss due to friction, means HF is we should calculate, and also power required, capital P, for the pipe length of L is how much? 1000 meters. And again kinematic viscosity of oil is given as 0.29 Stokes. I already told Stokes is a CGS unit, convert to SI. So 0.29 into 10 power minus 4 meter square per second. So ultimately what is that we need to calculate? HF and also P. So let's see how can we solve this problem. So first thing people, if you observe in the complete question, velocity is not given to us. Instead Q is given to us. So first let's calculate velocity. So velocity is given by q by a, because when q is equal to a into v, of course v will be q by a. So this is 500 into 10 power minus 3 by area of the pipe formula is pi by 4 d square, which is pi by 4 of 0.3 square. So let's see how much we will get the velocity. So the velocity is 7.07 meter per second. Now once you got the velocity, what we have to do? We will calculate the Reynolds number, because kinematic viscosity is there. Again Vd by nu. So 7.07 into dia is 0.3 by what is this value? 0.29 into 10 power minus 4. So the Reynolds number comes out to be around 7.3 into 10 power 4, which is obviously greater than 4000. Again we apply coefficient of friction formula or the friction factor formula as 0.079 by Re power 1 by 4. So from here 0.079 by what is Re? 7.3 into 10 power 4 to the power of 1 by 4. So our friction factor came out to be 0.0048. So we have friction factor ready, we have velocity ready. So we can calculate what now? HF. Therefore, head loss due to friction, HF is equal to, formula is 4FLV square by 2GD. So HF is equal to 4 into F, how much we got just now? 0.0048 into L is how much? 1000 into what was the velocity? 7.07, correct, whole square by 2 into G is how much? 9.81. What is dia? 0.2. We get HF to be as around approximately 163.18 meters. We are not yet done. He also asked us to calculate the power. So power required formula, I am writing it here. Capital P is rho G Q HF by 1000 in kilowatts. Okay, let's put up this formula. 1000 into, sorry, 1000, not 1000, it is 700, because for us in the question the value of oil we have calculated, density of oil. So let's multiply 700. If it is water, we put 1000. So 700 into 9.81 into what was our Q? 500 into 10 power minus 3 into HF 163.18 by 1000. So finally let's see how much we will get the power value. We got 560.28 kilowatts. Okay, so like this we have to solve problem regarding the head loss and power required. So if you people want to download the notes of this complete derivation and the numerical problems which I have solved in this video, please click the description of this video. You will have the link. Click on the link and download the notes. Hope all understood. Thanks for watching.